Hello students, welcome to EPG Pathsala. You are listening to Dr. V. Premala Priyadarshini from the Department of Food Service Management and Dietetics, Avinashlingam Institute for Home Science and Higher Education for Women, Coimbatore. I am here to teach you on the topic Dietary Management in Vitamin A Deficiency. Today's presentation of mine will have a brief introduction on vitamin A, their functions, deficiencies, the various management tools to combat the deficiencies, and of course the summary of what we have learned. Vitamin A is an important micronutrient required for maintaining normal growth, regulating cellular proliferation and differentiation. It also plays a key role in the development and maintenance of visual and reproductive functions. Diet surveys have shown that the intake of vitamin A is significantly lower than the recommended daily allowance in young children, adolescent girls and pregnant women. In these vulnerable subgroups, multiple nutritional problems such as inadequate intake of energy and micronutrients other than vitamin A also coexist. Many studies reveal that around 250 million preschool children are vitamin A deficient, and it is likely that in vitamin A deficient area, a substantial proportion of pregnant women are vitamin A deficient might as well. It is estimated that 2.5 lakh to 5 lakh of vitamin A deficient children become blind every year, and half of them die within 12 months of losing their sight. In Tamil Nadu alone, 7.5%, that is 9 out of 120 children in the capital city go blind due to vitamin A deficiency. On the other hand, 30.4%, that is 51 out of 168 in rural area go blind because of vitamin A deficiency. With this brief introduction, this current module will make you to gain knowledge on the functions of vitamin A and its importance, understand the different deficiency disorders of vitamin A and their dietary management. So let me start our today's lesson on vitamin A and its functions. Vitamin A are a group of nutrients needed in small amount by the body to maintain health. Vitamins cannot be synthesized by human body, and so they can only be derived from dietary sources. Certain vitamins are water soluble and some are fat soluble, namely vitamin A, D, E and K. Students, remember that vitamin A exists in the form of retinol and performs several functions. The first and the foremost one is that it plays an important role in the formation of vision. Retinol is transported to retina, fine hair-like structures located at the back of our eyes, where it is oxidized to retinal. When needed, retinal can be transported to the rod, that is the photoreceptor cells, where it binds to a protein called opsin to form visual pigment rhodopsin. Rod cells with rhodopsin can detect very small amount of light, making them very important for night vision. Absorption of photon of light catalyzes a transformation of retinal and results in its release. This triggers a cascade of events leading to the generation of an electrical signal to the optic nerve, which is interpreted by the brain. A lack of retinol available to the retina results in impaired dark adaptation known as night blindness. Secondly, vitamin A in the retinoic acid form plays a very important role in the regulation of gene expression. Once retinol has been taken up by the cell, it can be oxidized to retinane, which again can be oxidized to retinoic acid. Retinoic acid can bind to different nuclear receptors to initiate or inhibit gene expression. Through the regulation of expression of specific gene, retinoic acid plays a major role in cellular differentiation, the specialization of cells for highly specific physiological roles. Thirdly, vitamin A is required for normal functioning of the human system. Retinol and its metabolites are necessary to maintain the integrity and function of skin and mucosal cell, to act as a barrier and fight against infection. Vitamin A plays a central role in the development and differentiation of white blood cells such as lymphocytes, which plays a critical role in the immune response. Fourthly, vitamin A is essential for embryonic development. During fetal development, it helps in the development and formation of heart, eyes, and ears. Additionally, retinoic acid has been found to regulate expressions of genes for growth hormone. Both vitamin A excess and deficiency are known to cause birth defect. Fifthly, vitamin A is required for normal development of precursor cells, I mean the stem cells, into red blood cells. Additionally, vitamin A appears to facilitate the mobilization of iron from storage site to the developing red blood cells for incorporation into hemoglobin, the oxygen carrying blood cells. The vitamin A metabolism is thought to interfere with zinc and iron in several ways. Zinc deficiency results in decreased retinol transport, decreased retinol release in the liver, and a decrease in conversion of retinol into retinane. Vitamin A supplementation has beneficial effect on iron deficiency anemia, and it improves the nutritional status of iron among children, pregnant women. The combination of supplemental vitamin A and iron seems to reduce anemia more effectively than either supplementation of iron or vitamin alone. Having seen on the functions of vitamin A, let us now learn the consequences of vitamin A deficiency. Vitamin A deficiency leads to loss of globulate cells in the conjunctiva. Yes, you're right, a membrane that covers the outer surface of the eye. Globulate cells are responsible for the secretion of mucus, and their absence result in xerophthalmia, a condition where the eye becomes dry and fails to produce tears. Progressive deficiency leads to the accumulation of dead epithelial and microbial cells on the conjunctiva and forms a debris or a dirt that can lead to infection and possibly blindness, resulting in night blindness. Night blindness is the difficulty for the eyes to adjust to the dim light. Affected individuals are unable to distinguish images in low level of illumination. People with night blindness have poor vision in the darkness but sees normally when adequate light is present. Vitamin A deficiency affects vision by inhibiting the production of rhodopsin, the eye pigment responsible for sensing low light situation. Rhodopsin is found in the retina and is composed of retinane, an active form of vitamin A, and opsin, a protein, as we have already seen. Because the body cannot create retinal in sufficient amount, and a diet low in vitamin A will lead to a decreased amount of rhodopsin in the eyes, as there is inadequate retinane to bind with the opsin. Night blindness results. It also causes thinning and ulceration of cornea on the surface of the eye, leading to keratomalacia. Oval, triangular or irregular foamy patches on the white of the eyes called bitoid spot results due to collection of keratin in the conjunctiva. With respect to skin and hair, deficiency results in dry skin, dry hair and itching. Remember that imtiaz's sign is the earliest ocular sign of vitamin A deficiency, and the conjunctival epithelial defects occur around later aspect of Limbus in the subclinical stage of vitamin A deficiency. Night blindness and its worsened condition, xerophthalmia, are the typical markers of vitamin A deficiency, as it can lead to impaired immune function, cancer, and birth defects. Now, coming to the treatment, mild form of vitamin A deficiency can usually be treated without any long-term problems. Vitamin A deficiency is much more common in developing countries like India, where it is often very severe and can cause loss of vision and even death. A regular intake of vitamin A rich food will usually prevent vitamin A deficiency as long as you do not have any long-term conditions preventing your body from using the vitamin A in your diet. Liver, beef, chicken, eggs, whole milk, fortified milk, carrots, mangoes, orange, sweet potatoes, spinach, and other green leafy vegetables are among the foods that are rich in vitamin A. Eating at least 5 servings of fruits and vegetables per day is recommended. Various foods such as breakfast cereals, pastries, breads, crackers, and cereal grain bars are often fortified with vitamin A. Never forget that for people at increased risk, especially young children, vitamin A supplement can reduce the risk of symptoms, permanent loss of vision, and of course, the risk of death. Decreasing night blindness call for enhancing the vitamin A status and the at-risk population. Supplement and fortification of food have been shown to be effective interventions. Supplement treatment for night blindness includes a massive dose of vitamin A, that is 200,000 international unit, in the form of retinol palmitate to be taken by mouth, which is administered 2 to 4 times a year. Intramuscular injections are poorly absorbed and are ineffective in delivering sufficient bioavailable vitamin A to our body. Fortification of food with vitamin A is costly but can be done in wheat, sugar, and milk. Consumption of yellow-orange fruits and vegetables rich in carotenoids, specifically the beta-carotene, provides provitamin A, a precursor that can prevent vitamin A deficiency related to night blindness. However, the conversion of carotene to retinol varies from person to person, and the bioavailability of the carotene in food varies. The richest animal source of vitamin A, the retinol, are liver, like beef liver. 1 ounce produce around 8,000 international unit, and cod liver oil, a teaspoon of it produce around 4,500 international unit of vitamin A. Treatment of vitamin A deficiency can be done by administering retinol palmate orally or intravenously. As an oral form, the supplementation of vitamin A is effective for lowering the risk of morbidity, especially from severe diarrhea, and reducing mortality from measles and all causes of mortality. Studies have shown that vitamin A supplementation of children under 5 who are at risk of vitamin A deficiency can reduce all cause of mortality by 23%. In countries where vitamin A deficiency is treated as public health problem, they address it by the elimination of administering vitamin A supplement in the form of capsules on national immunization days, along with polio and measles vaccines. Additionally, the administration of vitamin A supplements through ICDS programs have helped to ensure a high coverage of vitamin A supplementation in large numbers, specifically in developing countries like India. The benefit of vitamin A supplement is transient. Children need them regularly every 4 to 6 months. Maternal supplementation benefit both mother and breastfed infants. High dose of vitamin A supplementation to the lactating mother in the first month can provide the breastfeed infant with an appropriate amount of vitamin A through the breast milk. However, heavy dose of supplementation to pregnant women should be avoided because it can cause miscarriage and birth defects. Food fortification is also one of the useful way for improving vitamin A deficiency. A variety of oily and dry forms of retinol ester, retinol acetate and retinol palmitate are available for food fortification. Margarine and oil are the ideal food vehicles for vitamin A fortification. They protect vitamin A from oxidation during storage and promote absorption of vitamin A. Beta-carotene and retinol acetate and retinol palmitate are normally used as a form of vitamin A fortification of fat-based foods. Fortification of sugar with retinol palmitate as a form of vitamin A has been used extensively throughout Central America. Cereal flour, milk powder, liquid milk are also used as food vehicles for vitamin A fortification. Dietary diversification can also control vitamin A deficiency. Non-animal sources of vitamin A which contain preformed vitamin A accounts for greater than 80% of intake for most individuals in the developing world. The increase in the consumption of vitamin A rich food of animal origin in addition to fruits and vegetables has beneficial effect on vitamin A deficiency. The National Prophylaxis Program Against Nutritional Blindness is being implemented in the country since 1970 through health and family infrastructure. The program today covers 30 million children under 5 years of age and utilizes the short-term strategies of administering a mega dose of vitamin A solution periodically given to the children under 5 years of age and the long-term promotion of dietary intake of vitamin A. The program is not extended to children between 6 and 11 months and is proposed for 6 months to 3 years old children. The ultimate solution for the prevention of vitamin A deficiency lies in educating people to eat food that are rich in vitamin A. Breastfeeding will protect children from vitamin A deficiency during the first 6 months. From the age of 4 to 6 months, it is crucial to introduce semi-solid foods containing vitamin A such as dark greens and yellow leafy vegetables and fruits, and to ensure adequate intake of vitamin A by preschool children and pregnant and lactating women. The implementation of the national program can be achieved only by training the health delivery team and the functionaries of the Integrated Child Development Scheme, yes, the ICDS. Administration of a massive dose of 2 lakh international unit of vitamin A in oil orally for every 6 months to preschool children showed a significant reduction in the prevalence of ocular signs of vitamin A deficiency. Since vitamin A can be stored in the liver for a prolonged period, the first dose of 1 lakh international unit of vitamin A is administered at 9th month of the age along with the measles vaccine. The subsequent doses of 2000 lakh of international unit are given at 18 months along with TPT booster dose at 24, 30 and 36 months. Children in the age group of 3 to 6 years are also covered under vitamin A deficiency control program by providing nutritious noon meal in the center. This meal consists of 80 grams of rice, 10 grams of dal, 2 grams of oil, provides egg thrice a week, green gram, Bengal gram sundal, potatoes are also given. The IFA supplementation, the vitamin A administration, mass deworming biannually are also done. The content of provitamin A is also influenced by many agroclimatic factors such as season, growing conditions, stage of maturity at the time of harvest, plant variety, and many steps in post-harvest handling, processing techniques, and during marketing. Fortified foods are important source of vitamin A. Red palm oil is very rich source of vitamin A precursor, the beta-carotene. Food-based approach are the broad-based projects. They offer assistance in setting up homestead food production, improving the productivity of home garden, and in keeping small and dairy animals. However, they also raise awareness about vitamin A deficiency and give education about storage and food processing. Successful projects works with local NGOs at grassroots level. Once the gardens are established, they prove to be sustainable in providing all year-round availability of diversified foods that are rich in vitamin A. This not only improves the vitamin A status, especially of women and children, but also improves the status of other essential vitamins and minerals. Homestead food production often generates additional small income which can be spent, often by women who produce them, on other food products, education, or assert to improve the garden. The role of vitamin A supplementation in the prevention of respiratory infection among the children have concluded that supplements should only be given to children with poor nutritional status. The result also suggests that the dosage and the potential adverse effect are important consideration when making recommendations. Overdosage of vitamin A can cause toxicity that is associated with nausea, vomiting, and loss of appetite, and that can further reduce nutrient intake. Administration of moderate dose of vitamin A results in a positive effect among children with sufficient dietary intake. Better access to food rich in provitamin A, such as mangoes and papaya, may therefore be necessary under these circumstances through dietary diversification, homestead food production program. Remember, supplementation in form of vitamin A capsules will always be a necessary step for specific situation, be it during pregnancy and breastfeeding, in refuge camps, or after natural catastrophe. Food fortification is a complementary approach but is restricted because can only focus on specific vitamin and nutrients. The most sustainable strategy is a diverse diet through which everybody gets the necessary amount of vitamin A along with other vitamins and minerals. Home garden and homesteads are the best option to do that because they offer a secure supply of diverse food. In such a system, it is not necessary to count the amount of each individual vitamin A. The goal is a secure supply of micronutrient, a healthy diet that contains everything that is needed. Food fortification and medical supplementation are supply driven and beyond individual control, whereas home garden are sustainable solution at household level. Remember that it is true food-based approaches usually take longer time to implement, but once established, they are highly sustainable. The goal of combating vitamin A deficiency is not to provide medical treatment, is to avoid vitamin A deficiency and other vitamin mineral deficiency syndromes. By combating vitamin A deficiency with home garden, sustainable systems are created that provides food security and diversity in a way by empowering women and protects agrodiversity. To summarize, students, so far we have learnt about what vitamin A is all about, its functions, particularly the role of vitamin A in the formation of vision and the growth of children at their early stages, the clinical manifestation of deficiencies, the various management strategies right from dietary supplementation, prophylactic measures such as mass immunization and fortification to Homestead's sustainable approach of kitchen garden and nutrition education to combat this major deficiency. Students, always keep it in mind, the strategy to prevent vitamin A deficiency should be a combination of a long-term program of nutrition education and improvement in household food security and a short-term periodic massive dose of vitamin A. And of course, there's also a need for intensification of research and developmental activities to identify technologies to increase the production and consumption of less familiar beta-carotene rich foods such as red palm oil, spirulina, blue and green algae to march towards a healthy India. Thank you for listening. Enrich yourself with more learning. Have a good day.